I am Dr. M. Balaji, Assistant Professor of Physics working in Saurashtra College, Madurai. Today I am going to deliver a lecture on Bohr atom model. As we all know, after the discovery of Rutherford backscattering experiment, Bohr has derived the relationship for the electron and the nucleus. Meanwhile, he is the first person who gives the relationship, and he clearly suggested electrons cannot revolve around the nucleus in all permissible orbits as suggested by the classical theory. He has proposed different permissible orbits for an electron, and its angular momentum is the integral value of the h cross, which is h by 2 pi. And he has suggested when the electrons are in stable condition, that won't emit any energy of photons. When it jumps from the higher orbital into the lower orbital, then only which emits the radiation, that is the important second postulates. So in these second important postulates, he has derived the frequency value of the electron also. So here the quantized angular momentum, which is in the value of L equal to nh cross. N is the principal quantum number, and he has suggested in a stationary orbit that won't eject any radiation of photons. When the electrons comes from the higher orbital into the lower orbital, then only which ejects the photons. Here we can see the stability condition of the stationary electrons. The charge of the nucleus, which is equal to plus Ze, and the radius between the nucleus and the electron, which is r. The balanced condition of the nucleus and the electron, which is maintained mainly because of the equal values of the centrifugal force with the electrostatic force of attraction. When these two values are balanced to each other, then only the stability of the atom which is existed. So here we can see the centrifugal force mv squared by r between the electron and the nucleus, and the electrostatic force of attraction, which is equal to 1 by 4 pi epsilon naught Ze squared by r squared. So as suggested by the Bohr, the first important postulates, the angular momentum value L equal to m into v into r, which is equal to nh cross. So when we compare these two stable equilibrium values, which is centrifugal force and the electrostatic force of attraction in a stationary electron, here we can get the equation mv squared by r, which is equal to 1 by 4 pi epsilon naught Ze squared by r square. And in the meantime, as suggested by the Bohr, this mvr, which is angular momentum value, which is equal to nh cross. So from this relation we can get the value of v squared, which is equal to n squared h squared divided by 4 pi squared m squared into r squared. When we substituting these values in the first equation, we can get m by r into v squared here. So instead of this v squared, we can substitute n squared h squared by 4 pi squared r squared m squared, which is equal to the value of 1 by 4 pi epsilon naught Ze squared by r squared. When we cancel the terms, finally we can get the value of r, the radius of the nth permissible orbit for electron, which is equal to n squared h squared into epsilon naught divided by Ze squared pi m. So this is the value of the permissible orbit radius Rn value. If we consider for a basic element hydrogen Z equal to 1, so we can write n squared h squared epsilon naught divided by pi e to the power 2 into m. Here we can see the r value is directly proportional to the n square, which is the principal quantum number. So here this is the equation as we seen earlier. In the nth orbit, the formula has been written as Rn, which is equal to n squared h squared epsilon naught divided by pi e squared m. Here the n value is the principal quantum number and h is the Planck's constant, which is in the value of 6.625 into 10 to the power minus 34 joules second, and the epsilon naught is the permittivity of free space. So here we can say the Rn value, which is directly proportional to the n square. So the radius ratio has been maintained as the n squared value 1:4:9, 3 squared 9 and 4 squared 16, like that it will be present. And from that relationship he has derived the total energy value. We all know the total energy, which is equal to the combination of potential energy and the kinetic energy. The potential energy, which is nothing but when we bring over the electron in an orbit from the infinite distance to that finite level, the work done in bringing the electron from infinite to that orbit, which is called potential energy, right? So we are doing work done from the infinite to that particular orbital r value. So when we integrating this term, integral over r infinity to r z e squared by 4 pi epsilon naught r squared into dr, which is equal to when we integrating this term we can get minus z e squared by 4 pi epsilon naught r. Meanwhile the kinetic energy term of the electron, which is equal to half mv squared, which is equal to, we all know the value of mv squared from the previous equation. So when you substituting this equation, we can get the kinetic energy of the electron, which is equal to z e squared by 8 pi epsilon naught r. Here we have 1/2, so it will convert into 8 pi epsilon naught r. So the total energy value, when you add these two values, potential energy and kinetic energy, we can get minus z e squared by 8 pi epsilon naught r. When you substituting these values in the total energy term, which is equal to minus m into e to the power 4 z squared by 8 epsilon naught squared n squared into h squared, right? So here these are the potential energy term and the kinetic energy term. The total energy value, which is equal to minus z e squared by 8 pi epsilon naught r. Here you can see these values, the sum of potential energy and kinetic energy, which reveals that the total energy is exactly half of the potential energy, and the final energy formula, after substituting this value of r, we can get the energy term En. Here you can see the value of En, which is directly proportional to z square, which is the total energy is directly proportional to the square of the atomic number. So he has derived this relationship. Conclusively, Bohr has derived two important postulates, and the first important one is the electrons only occupy permissible orbits where its angular momentum is an integral multiple of h cross, and in the stationary orbit electrons won't emit any energy of photons. It's a highly stable condition. Electron doesn't emit electromagnetic radiation in this state. When the electron jumps from the higher orbital into the lower orbital, it will eject the energy, and the orbital radius has been maintained as 1:4:9:16, like that. So these are the terms he has derived, and he has, from this relationship he has derived the permissible orbit radius of Rn equal to n squared h squared epsilon naught divided by Z pi E squared into M, and the total energy value En equal to minus me power 4 Z squared by 8 epsilon naught squared n squared h squared, and the energy photon energy, which is equal to, so which is mainly depends upon the frequency. So the frequency value nu equal to higher energy of the higher orbital minus energy of the lower orbital divided by h. So these are the basic terms we should understand first to to know the Bohr atom model. Thank you.